if you have this type of trinomial, which is a perfect square trinomial, it can be factorized into two factors or two same binomial. The second case now, that if you have the same a squared and b squared too, but you don't have anything between them. Here we say that we have a 2ab. Here you don't have anything between them. You have a minus sign, which we call them a difference of squares. If you have them like this, a squared minus b squared, it can be factorized into a minus b times a plus b. So if you have two squares, okay, two squares, and these two squares have a sign, minus sign between them, it will be factorized into two different binomials, a plus b and a minus b. But if you have them like trinomial, not binomial, this is a binomial. If you have them in a trinomial, and we call them specifically as a perfect square trinomial, it could be factorized into a plus b times a plus b. It will be the same. The first one, we call them perfect square trinomial, and the second one, we call them a difference of square. Let's now talk about the difference of a square. Now, as you remembered in lesson 4 also. In lesson 4, we said that if you have x minus 5 times x minus 5, we said that it was x squared minus 10x plus 25, because we wrote the square of the first term, the square of the last term, then I multiply x times negative 5, which is negative 10, which is negative 5, sorry, times 2, we will get the middle term. This is how can we multiply two factors which are the same. And we said, but if we have two factors have the same number, a different sign, like x minus 5 times x plus 5, what did we say? We say we wrote the first square of the first term, sorry, minus the square of the second term. In lesson 4, we learn how to multiply x minus 5 times x plus 5. You will get x squared minus 25. In this lesson, I will do the reverse step. I will tell you, if you have a x squared minus 25, how can we write the two factors of the pair of factors of them? Now, for all real numbers a and b, if you have a squared minus, it must be minus b squared, I will take, the first step, I will open two brackets. I will put, I have a squared, one a here, and the second a here. B squared, one b here, and the second b here. Then, then I told you, if I have a difference of squares, one, it must be plus, and then the second, it must be minus. Let's have an example now. Look at this example here. We have a z squared minus 9. I want to factor this difference of 2 squared. What do you have to do? The first step, don't forget, you must write them as a square. And is a 9 is a perfect square? Yes, it is a 3 squared. Is it right?
Yes.
Yes. So because of that,
Yes.
so after that, since I have them like this step, z square minus 3 square, I will open two brackets. Why two brackets? Because you have two terms only with a minus sign between them, or you have a difference of two squares. If you have a difference of two squares, I will open two brackets. Then I have z squared. I have two z. One is here and one is here. Then I have 3 squared. I have 3 here and 3 here too. But since I have a minus sign, okay, I have a minus sign, I will put, did you remember when I told you that if C is minus, it's like this, you have to remember it. If C is minus, that means you have different signs. When you're factorizing, yes. So one is minus here and the second one is plus here.
Yes.
That's it. This is the way how can we factoring a difference of two squared. Let's check them. If you multiply them, will I get a z squared minus 9? Let's see. I will now clear this. Let's move it here. Let's now multiply them using the table, the FOIL, as you want. Z times z, then z times positive 3. Z times z is z squared. Then z times positive 3 is positive 3z. Then let's multiply negative 3 times z and negative 3 times 3. Negative 3 times z is negative 3z, and negative 3 times 3 is negative 9. Then look here, 3z minus 3z. Can they cancel each other?
Yes.
Yes, it will be 0. So what is
0?
Yeah, 0. What is left here? It will be z squared minus 9. So z squared minus 9, it will be factored to z minus 3 times z plus 3. Is it clear?
Yes.
So,
Yes, teacher.
now, so by now, if you have as z squared minus 9, or if you have it as z squared minus 18z plus 9, or if you have it as z squared plus 18z plus 9, or if you have it as, oh, wait, please. And this. Like this, okay. If you have them lined out like this, the first one here, look at the first one. We have a difference of squares. I will open two brackets. Z here and Z here. This 9, it is a 3 squared. I will write them, one 3 here and the second 3 here. And since they are a difference of square, I must write a minus sign here and plus sign here. This is for the first one. Look at the second one here. The second one, did we have a difference of two squares or a perfect square trinomial? It's not a difference of two squares. It could be a perfect square trinomial. Let's see. Here we have z squared, and this 9 is a 3 squared. So we put z minus 3, and if you multiply negative 3 times, I'm sorry, here it must, okay, is around 6. Okay, it is. Now, if I multiplied z times negative 3 times 2, did I get the middle term?
Yes, teacher.
Yes, it's negative 6z. So it can be factored as z minus 3 squared. Or you can write them also as z minus 3 times z minus 3. And the second one down here, it will have the same steps, but this one here. So what I want to summarize from here, that if you have the two factors have the same sign, minus, if I have these two factors have the same sign, their trinomial is this one. And if you have these two binomial factors are the same, it's a trinomial. And if they have them but with different sign, that means I have this square. Oh, this is the, if you multiply them, you will get this is this binomial. So if you have a difference of square, you only get z minus 3 and z plus 3, 1 plus, 1 minus. If you have them as a perfect square trinomial, you must get two factors that they have the same number with the same sign. So only the two ones or the two things that can be factored into these two squares, a squared minus b squared, or a squared minus 2ab plus b squared, or a squared plus 2ab plus b squared. Only these three cases. What does it mean? That means if I have z squared plus 9, how can I factorize them?
By making two brackets having the same numbers but different signs.
No.
No.
I remember I told you difference of two squares. Anytime if you have a z squared plus 9 or x squared plus 16 or x squared plus 25, if I have a square, perfect square, another perfect square, but I have a plus sign between them, I will say it cannot be factorized. I must have a different sign, a minus sign between them. So what does it mean? That means if I have an x squared minus 25 and x squared plus 25, this one, it cannot be factorized. I told you I must have a difference of two squares. But for the first one, yes, it can be factorized. Is it clear?
Yes.
Yes, miss.
I must have a difference sign.
Okay, teacher.
Teacher, one of you asked me, teacher, what if I have x plus 5 times x plus 5? I told you I must have, the answer is perfect square trinomial. Now, what is the factored form of each expression? V squared minus 100 and S squared minus 60. The first step, let's write them here as a V squared minus, is a 100 is a perfect square?
Yes.
Yes, it's a 10 squared. Then, are they a difference of squares?
Yes.
Yes. Since they are a difference of squares, I will open two brackets. One of the V here and the second V is here. One of the 10 here and the second 10 is here. And since they are a difference of squares, one is minus and one is plus. Is it clear?
Yes.
Yes, miss.
Yes, teacher.
Okay, look at the second one here. S squared, sorry, minus 16. Let's write the first one as S squared. And the second one is a 16 is a perfect square?
Yes. 4 squared.
Yes, is it a perfect square because it is a 4 squared. Let's open two brackets now. One S here, one S here, 1 4 here, 1 4 here. And since we have a difference of squares, one is plus and one is minus. This is a way how can we factor or how can write the factored form of this expression. Is it clear now?
Yes.
Yes, teacher.
Yes, miss.
Like if you have an look at now these four examples here. X squared minus 49, x squared minus 48, x squared minus 14x plus 49, and x squared minus 14x plus 40. Now look at these examples here. Now let's factorize all of these expressions here. Look at the first one. I will look at the first term and the last term. Are they a perfect square?
The first term and the second
The first term and the
or-
last term. Here, this one and this one. Are they a square term? A perfect square, sorry?
Yes.
Yes. Since they are a perfect square, what does it mean? It can be written as
X.
two open
Two
brackets, x, x, and 49. You told me it is a perfect square, is it right? What is the number that I multiplied them with itself? I get 49.
7.
7. 1 7 here and 1 7 here. And since they are a different of two squares, I will say one is one minus here and one of the pluses here.
Yes.
Look at the second one now. X squared minus 48. Look at the two terms. Are they a perfect square?
No.
The first one, yes.
No.
But the second one,
No.
No.
no. 48 is
No.
not a perfect square. So I will say it cannot be factored. What
Factored
about?
in this way to square?
Yes, it cannot be factored. No, in this way or in another way.
Okay.
What if you have now an x squared plus 49? How can I factorize them?
Also, it cannot be
It
factorized.
cannot. Thank you. I told you it must be a difference of two squares. Now look at the one here. X squared minus 14x plus 49. Look at the first and the last term. Are they a perfect square?
Yes.
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 Squared and 49. Let's open a bracket. X, one from the x's, and the 49, as we said, it is 7. Then we have a minus sign here. 7, or negative 7 times x as a negative 7x times 2, negative 14x. So this is a square trinomial or a square perfect trinomial, and it can be factorized in this way.
Yes.
Now, look at the last one here. Look at the first term. Is it a square, perfect square?
No.
Yes.
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 The last term?
No.
It is
No.
not. So I will look at the factors of 40 that if I multiply them, I get a 40, and if I add them, I get 14. Let's open two brackets
10
now.
and 4. I mean negative
Since
10
we
and
have,
positive 4.
yeah, since we have here as positive c with a minus b, so we have minus minus, same minus, x, x. Now, what are the factors of 40? That's if you add them, you get 14.
20.
10 and 4.
No,
10 and 4.
10 and 4. Because 4 times 10 is 40, and
But you want
4
to
plus
multiply?
10 is 14. So, if you factorize now this one, the answer is x minus 10 times x minus 4. It can be factored, but not the same. Is it clear? By the way, this lesson is it's very important. You will need them in Sat 1, and you will need them in grade 11 also, grade 12 also, in calculus, I mean. You must know how can you factorize any trinomial or any perfect square trinomial or any difference of square. Is it clear?
Okay. Yes.
Yes. Yes. Yes.
Okay.
Yes, teacher.
Okay. No, but sometimes I have a problem. Like this one here. I have a 16x squared minus, this is not a problem, sorry, I'm talking about problem 5. This one here, I have a 16x squared minus 81. 16x squared minus 81. Look at them here now. Look at number 16. Is it a perfect square?
Yes.
Is
Yes,
it what?
Yes.
Is it yes?
Yes.
Is it what? 4.
4.
9
Square.
over 2.
4.
And the x
X is
Where?
about
The
2.
x
minus 81.
Minus
9.
9.
9 over 2
Thank you.
9.
Then
power.
let's now take the numbers. 4x here and the 4x here. The 9 here and the 9 here. Distribute the two nines into brackets. Distribute the 4x into brackets. And since we have a difference of squares, one is minus and the second is plus. Is it clear?
Yes.
Yes, teacher.
Okay.
Yes.
Let's have another example now. What is the factored form of 25d squared minus 64? Look at them here. 25 is a perfect square.
Yes.
Yes.
Yes, miss.
Sorry.
Yes,
It is a 5 squared.
5 squared.
And d squared minus
D squared.
64 is a
Minus
perfect. Thank you. Minus 8 squared.
8.
Now let's open two brackets.
4, but
5d,
5d, then
5d,
5d minus 8.
then minus 8 plus 8.
And then plus.
Minus
Thank
plus.
you. Thank you so
5d
much.
minus
One is
8,
minus
5d
and one
plus
is a plus.
1 and plus.
Now, look at B. The expression 225t squared. Now, before I go to B, is it clear?
Yes,
Teacher,
miss.
Yes, miss.
Okay.
I'll distribute for each term, teacher, in the 5d squared minus 8 squared. So I will distribute 5d in a bracket and 5d in another bracket.
Yes, Mish, we have a square, a 5d squared. That's when I have 5d and 5d. One on bracket and the second one in another bracket.
Okay.
So look at
teacher,
this one here. Yes.
when we factorize, 1 minus and 1 plus.
1 minus. So like
And
what?
1 plus.
Ah, you mean the perfect square trinomial. Okay.
Yeah, the perfect square.
Okay, look here now. 25d squared plus 64. How can I factorize them? I have a perfect square, yes. 5 squared, d squared, 8 squared. But I have here a plus sign between them.
Sorry, teacher, I go up because of the internet connection.
Okay, no problem, Basma. Now, look at this one here. Can I factorize them?
Yes.
Yes, miss.
No, teacher, it's plus sign, not negative sign.
Oh, yes, it is no.
No, we can.
I told
Miss,
you it is a difference. Difference of two squares, not plus. If you have a plus, you will tell me, no, teacher, it cannot be factored because it's a sum of two squares and it cannot be factored. I only can factor the difference of two squared. Now, it's clear?
Yes, teacher, not I'm writing only.
Yes,
not
ma'am.
this one.
Okay.
yes, teacher.
Now, sometimes, like this example here, you have a 24 g squared minus 6, and I want now to factorize them. But if you look at 24, sorry, minus 6, if you look at them, okay, look at the first term here. Is it 24? Is it a perfect square? Is it 24 from these yellow numbers?
No.
No.
No, miss.
And 6.
No, also.
Yeah. So,
No.
so, I cannot use the difference of two squares. The difference of two squares only through the square numbers. But here I have two